We are going to talk about PostgreSQL. Something I liked when I talk about PostgreSQL is that most of the time, when you get people talking about it, you get people talking about admin C stuff. Oh, the replication is so beautiful. In 9.1, you get performances, you get like table space, everything like this. I'm not going to talk about this. There are a lot of things I'm not going to talk about because I have only 40 minutes. And so at the beginning, when I made the slides, I made something like 160 slides. And I was really frustrated because with those amount of slides, I could only talk about 1% of what I wanted to talk about. So, I'm going to talk about something. In fact, I'm going to tell you a little story. It was something like 3 months ago. I just woke up from my bed, stand up and say, I get it. I know I can make objects from within Postgres and program directly from Postgres. So this is the story I'm going to tell you. First thing, we got a few things to understand. First, who I am. It's written there, I'm Grégoire Hubert. I'm the CTO of KNP Labs. KNP Labs, we are a small agency based in Nantes. We are doing Symfony 2. Sometimes we are doing Symfony 2, and most of the time we do Symfony 2. Sometimes, when we are going back home at night, we're doing Silex because it's fun. And we mostly deal with, all the Symfony component stuff. You can reach me on Twitter as well, and there is on the first slide here. If you want to leave feedback on the join in, that would be really, really appreciated. Slower? Okay. Okay. Wow, I have 40 minutes. So I'm going to talk about love. Because PHP is about elephants, and Postgres is about elephants as well. So we are going to talk about love between elephants. PostgreSQL, I won't spend too much time on that. Just first line of code has been written in 1986. First release in 1989, so it's not a young project. The guys today, we are the version 9.1 stable. They are really concerned about consistency. They are fanatic about consistency. This means that they won't let anything out if the result is not predictable. This is why it had some features only arriving at the present version right now. Data is more important than the code. In fact, that's a point of view. Most of the time, when you're just drawing application schema on a board, you talk about application, and database is something like a cylinder on the bottom of your schema. But if you look closely, at the beginning, of course, there's your little website with the database, and as it grows, sometimes you need more applications coming around the database. If you put some stuff only inside the application to get to ensure the consistency of your data, you will get stuck if you get other applications coming over your database. So sometimes it is important to ensure the consistency directly inside the database. This is what we are going to do. Structure and types, first part. Schemas. In fact, you don't know if you have ever used PostgreSQL before, you have used schemas. In fact, database is composed of schemas. Schemas contain all other database elements like tables, like types, like whatever. Here you can find, by example, the list of schemas I have on my personal database on my laptop. This means that I have almost all my own pet projects running in the same database. This is very handy because they act like namespaces in your database. This means depending on the SELs you've put on the objects inside the schemas and on the schemas themselves, you can access the objects or not from within one schema to another. This means that, for example, if you're playing with bundles, every bundles can have tables or other objects that will come into their own schema. This means there won't be any name collision anymore. So you can safely call your table, I don't know, comment or post for a blog post. There is no problem as long as you have put them in their own schema. Oh, okay. There is something we have to know. It's still about structure because, well, we do design database by constraints. And one of these constraints are types. Of course, PostgreSQL has a lot of all the basic types, integers, fixed, floats on all 4 and 8 bytes long. Characters, varying characters and text, Boolean, bit words actually, and variable bit. This means you can write words of bits for varying, sometimes very, very handy if you just want to store, I don't know, state or mask, if you want to use mask. Timestamps and intervals, timestamps with time zone or without time zone, depending on what you want. Binary strings, easy if you want to, I don't know, a little thumbnail of a blog outro, by example. Enumeration, blah, 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 blah. Well, a small overview of what you can do just with, by example, strings. Here, I just want to show, is this string with accent, please? So this means that it supports UTF-8. Is this strings is checked by this regular expression. You can see that the regular expression also accepts accentuated characters as well. Yes, this string check this regular expression. This is the PostgreSQL language for true. Can I split a string in a set based on a regular expression? Yes, I can. Out of the box come geometric types. Geometric types like point, circle, segment, box, polygon, and more. This means that if you want, you can have a geometrical representation of, I don't know, time, money, whatever, just to check with one of the awesome operators that come with Postgres. If, by example, this point located at 0, 0 is contained in the circle at 1, 1 with the radius 1. Obviously, it's not the case. So this means that you can use that in your queries directly. You can use that in your constraints as well when you build your tables and your subtypes. Are those two segments perpendicular? Yes or no? There is the same for parallelism, of course. Well, there are dozens and dozens of other operators like this. Directly, you can query your data this way. Some of you are going to love this one. The inet types, if you store, I don't know, DNSs, hosts, things like this, you can say, well, what is the nest mask of this host? I've chosen especially this network with this weird net mask. Is this host belonging to this network? So this means that in the query, you can directly select from my host table where hosts that are in this network. There are a lot of other operators as well. JSON, so I talk about JSON because it's the new hype, because, well, it looks like JavaScript version 8 is now part of the language supported as procedural language by PostgreSQL 9.2. So a lot of people started manipulating JSON directly inside PostgreSQL because there is the new type. So, well, just using the function row to JSON, directly applied to a table, will just spit out the world table as a JSON result. Some of them use them directly as a SOAP client. So now there is like a little Perl layer acting like a web server, just asking Postgres, hey, can you do something? Just calling stored procedures that spit out JSON. XML. XML has been in PostgreSQL for a long time. I've chosen to show you only one handy method of that, XPath. I don't know, have you ever used XPath before? Okay, you are web developers, okay. So you can do XPath in the database as well. By example, here, I try to grab the text of inside the tags pika and chu. And obviously, I have two answers. Look at this. What is that? No, it looks like a JSON, but it's not. It's an array. So this means that PostgreSQL supports arrays as well. Arrays of almost any types, I've talked previously. That can be null as well. So here I select an arrays of an N4, and I have an array. Having array structure into the database means I have operators as well. Because I know that ORMs, by example, do serialize PHP arrays to have like an array-like representation. But the thing is that you don't benefit from the operator. By example, here, I ask PostgreSQL, are any of those bin 2? And of course, it's true. I can ask, are all of them a condition on all or any of them? That could be an array of circles or array or whatever, IP addresses. Ah, yes. So the new trendy topic of PostgreSQL is doing NoSQL into the SQL. The hash source type is actually an extension of PostgreSQL, existing since PostgreSQL 8.4. It allows you to have like a key value structure into a field. So basically, it would mean that if you have the convenient tool, you could directly record PHP array into PostgreSQL as is. This is very useful because you can even query on one of those. Here is one example, query by example. I do select the value of the pika key where there is a key plop. Obviously, my set has only one row which satisfies the conditions, so it returns 2. So you can put whatever you want, only strings. So this means that you can have optional data, and you can even do queries on them into a table. You can also restrict some types. For example, here, I create a subtype on the point type. Lat long, which obviously is there to store latitude and longitude data. And I create a constraint to let only points being between -90 and +90, and well. And the most beautiful thing about this is I still can use the operator that was applying for the point type. So this means, by example, what is the distance between Notre-Dame and Cité Universitaire? Well, if I have the latitude and longitude, I just use the distance operator. And because this is going to give me angular distance, because it's about angles, I need to multiply by the circumference of the Earth and whatever, so like a constant which is roughly something like this. And it gives me 3 kilometers and 996 meters. If I check on Google Map, well, I have something like 100-meter error. So it can work for short distances, otherwise after that you have to create your own like little stored procedures to take into account that the row is, the Earth is round. Rows. It looks like you can combine types together to create a consistent set of data. They are rows. Because in the database, we are manipulating rows. In fact, we are manipulating sets of rows. So I can just say, OK, give me a row of this. And here is what PostgreSQL will show out. So true, which is a Boolean, and here the timestamp. Last thing, objects. Objects, well, it's not about object at the sense we are, in the sense we are just thinking. It's just that every time you create a view or a table in PostgreSQL, PostgreSQL automatically creates the according type. So this means here, if I have a city table with a varchar and a point to store latitude and longitude, obviously, then I have a city type. So I can just pick up the city type from the table, select city from city. I have one field result with as many rows as I have cities. So this means that you can manipulate directly records as they were only one value. I'm going to show what we can do with that. What we learned from that first part, there are no raw data. Raw data doesn't exist. If people talk to you about raw data, it's just they're wrong, because every data is intentional. That's very, very important to know that, because you can't just have data for having data. What is data for? I don't know, it's just there. That's nonsense. Data is here or not, so there is an intention behind each data. Behind each data, we also have structure. Structure is about constraint. And this is why the database has to be the reference of the structure, because in the database, everything is structured with constraints. I have no time to talk to you about check constraints, which is a great, great feature, about excluding constraints, which is an awesome feature. You can say, by example, I want to, I don't know, well, take a room like this one between 10 and 12, and you can place an exclusion constraint given, OK, on the time range, I use the overlapping operator, not people to occupy this same room during the same time. So you can put that directly on an index, so PostgreSQL will prevent people occupying the same room in the same time. Well, if you don't use, of course, the database to put the constraint, you will have to do that in the PHP layer, or won't do that at all. Let's go and dive into Postgres, because now we just saw little samples of code. It's not a troll. Actually, he did really say that, Linus Torvalds. What I did put that, because it's very important to realize that every time you are manipulating data, the way you take them from somewhere is really, really important. If you take inconsistent data, you have to prepare them before doing anything with them. This is called presentation layer. Presentation layer is the art of ordering data before doing some computation on them. The more chaos are your data, the more complex will be your computation, the more hard it will be to test them. So this is why Linus and I, believe that data structure and their relation is more important, because this makes your computation simple. Sets. Well, we are manipulating sets of rows. And sets, this is something which is output by any SQL statement, select, obviously, you know this one, but you may not know that you can also output rows and sets with insert, update, and delete as well. And we will be able to combine them together. So sets generator, you can believe that, oh, well, that's useless. That's so useful. That's so useful. Every time, by example, you want to, I don't know, create statistic on a month basis, if there is nothing happened during a month in your database, it won't be able to output you this month to say nothing happened during this month, because it just doesn't have the information this month did exist. So you first have to generate, by example, month from 1 to 12 to check, did anything happen this month? Yes, no, so 0 will be output. Fixed set. At first glance, you can say, well, this is even more useless than the first example. In fact, this is so useful, it took me ages to understand, wow, something I can do with that. If you join such a set with a query on the table, by example, you can say, okay, I want the 5 more producing factory from the US, 3 from the China, 2 from Europe, and 10 from, I don't know, Africa. This in one query. Tables are just persistent sets. They're just like sets, but they're persistent. That's it. By definition, sets are extendable. This means that, by example, here, well, something I like, I just discovered that a month ago. Instead of doing select star from something, you can just do table something. Well, it made my day. If I want to extend, by example, the urban area table we've seen previously, well, I can still use the star over there, and then add a new field in my set, which, by example, in this case, will hold density, population per area, per kilometer square. So very easily, I can extend my sets by adding extra fields. This is very convenient, because we just previously saw that we had numerous types and numerous operators. I don't talk about all the mathematical functions, statistical functions, cosinus, sinus, and whatever, and all the scientific computation you can do directly from within the database. So here, if I need urban density, of course, if you use an ORM, you will do, okay, I can just, I don't know, create a new getter that will calculate on the fly the average value, the density. Well, that will work. And here is the result. But by example, if you want to show the ranking, show me the worldwide ranking of the urban areas based on the population, and also per country ranking. If we do that in PHP, I wish you good luck. Here is how we do with Postgres. Window functions. Window functions are functions that works on window, on data window. So we use the rank function, which obviously rank the results, based on a window, order by population, descending. So this will be on the whole result set, so for worldwide results. So I'll alias this field as world rank. And here I create a window partitioned by country, order by population, descending order, as country rank. I just added my set with two extra fields, which give me this. There are some more window functions. You can, by example, ask, give me the previous, give me the following, give me accumulated sums or whatever percentage, what you want. Because window functions are very useful to create a result based on each row to another. So by example, if you have a forum, you can say, okay, for this thread, this user has been, I don't know, the more funny or whatever. Let's see how we can flatten sets. Flattening sets, well, of course you can just delete some rows by adding conditions after you where, but that's filtering. You can flatten them using aggregate functions. Aggregate functions, everybody know that because, well, everybody know count, star. I've discovered recently that you can even provide a name into the count. If here I use count based on the column name, only non-null result will be counted. That's maybe very useful sometimes. And sum of the population. Well, that's everybody know how to do that. So here are the results. So you can see China is probably the country that holds the most urban area in the world. Here are some aggregate functions. Count, average, obviously, min, max, sum. Bool and bool or. Maybe very, very handy sometimes. It just return the bool and say, okay, on this field, if all the fields are true, the aggregate will be true. And the or apply an or conditions on all the columns it aggregates. Array ag, aggregate everything in an array. String ag, aggregate everything in a string with a separator if you want. XML ag, should I need to describe this one? Variance, covariance, sample, correlation, and all the statistical stuff you can find. If you don't find your need into the statistical aggregates from Postgres out of the box, note that PostgreSQL supports the R language as procedural language. Retrieve the UI names per country. By example, that's nice. We know that China holds 41 urban area. Wouldn't that be nice if we could retrieve all the names? Yes, we can, using array ag. Here, it will aggregate all the names into an array. Here it is. So this means I'm able to say, per country, I've flattened all my sets. I have 41 area, and here are, well, I've truncated the list, of course, because, well, it won't fit on one screen. Here are the list of their names. We are approaching this morning, I woke up to understand, wow, I can do relationship from within Postgres. Wouldn't that be nice if we use object instead just name? Saying, give me all the urban area as cities per country. Here it is. So I was using this before this beautiful and sunny morning. I just realized, wow, what I did. I did fetch a one-n relation with one query, the father and all his sons. Let me explain that to you. By example, take another example. I have author and tweets. All of you almost, I think, tweet. So you know that we have here one n relationship between those two tables. You have the author and several tweets. In your previous life, to retrieve all the authors and their tweets, what did you do? Well, select star from author. And for each author, you say, okay, select all the tweets per author, and then I have everything I needed. But this would result in n queries. Here, if I do array aggregate, well, okay, how can I fetch everything in one query? If I use array aggregate, what can I do? Well, fetch the author and aggregate the tweets based on the, yes? Can you sort the tweets as well? Yes, we'll see that just after. but that's an excellent question. Here it is. So here I have tweet objects as an array for each of my author. I stopped using ORMs since that day.
And how does the PHP driver for Postgresql actually
No.
translate that into?
No, this is what we are talking about. I'm going to talk about that one as well. But that's an excellent question because, well, that's a problem, that's true. And I'm going to talk about this. Let's go a bit further. Common table expression. In your previous life, I mean, before this conference, sometimes you had to do subselects. That's the worst moment of a day doing a subselect because, well, they are not easy to write. They're tedious to debug because you often have to debug subselects. If we want only the most crowded UR for each country, which is a bit like what you asked, we used to do something like this. Something like, well, from urban area, join, select, alias, column, something. I want to first retrieve all the urban area, sort them by population for each country, and then retrieve them per country. Common table expression is just about saying, okay, show me your subselect and alias them. Here, I can do, okay, I'm going to create a set, which is, we know already this one, select name and rank over a partition per country. So I have the ranking based on the population. And here, I have my real select name, country, population from urban area, natural join sorted area, which is the set we have just defined above, where rank equal 1. Rank, I've defined it there. So this is the same thing with a bit less performance, I must say, but this is the same thing as doing a subselect. But this is 1,100,000 times easier to develop, to read, to understand, and to debug. Here we understand clearly that we are dealing only with sets. I'm declaring a set over there, and I natural join sorted area SI here. Natural join means, hey mate, you got the same columns, aren't ya? So let's mix them with the name. So naturally what he's going to do is say, okay, that's true, I have a name over there, and I have a name over there, so I'm going to do the join by name. There it is. Well, we just said that tables were persisted sets. So there are persisted sets, create table pk as select. Generate series, here we'll generate 100 records, and every time will give me, here I have a second column which I name data, which will be a random data, by example, and I will have a created at, which I set with a timestampable behavior. So I can do that. If you want to create, by example, temporary tables, you can just create temporary tables, and you can even tell Postgres not to log them. So they will be 100 times faster, especially for write operations. Well, that's the result, obviously. Last but not the least, Vritable CTI. In fact, normally you say, okay, select returns me set. But in Postgres, you can also use the returning statements on all the other statements, insert and delete. So this means here what I'm doing delete from document where is finished, equal true, obviously, returning star. So PostgreSQL deletes all those things where is finished is true and returns everything. So this acts like as a select. Return me everything you just deleted from this table. With that statement, I do another statement here, insert into archive select star from deleted documents, which is a set I've defined over there. So this means instead of having a document table with 100 fields, like is deleted, yes, and when deleted, I want this field to be active, this field to be active, which result in 100 of nullable fields, sometimes used, sometimes not. I can simply have two different tables holding two different types of objects. One of them are active documents, and the other are archive documents. They can have different fields, and they can be transferred this way. And this is atomic. This is only one transaction. Oh, well, this is the demo time. Foreign data wrapper. This means that you can also see all the world through the database. This means that you can map on a local table resources, foreign resources. Obviously, foreign resources can be, well, tables on another database, tables on another server, tables on other server brand. No, don't read that. Web service, and whatever you could code. Well, this is in Python right now, but there are a lot of foreign data wrapper written with that. If I've done my job correctly, I should create a new table as select these fields from www foreign data wrapper Twitter, where the tweets contain hash from, not from PHP, come on. What would be there? SymfonyLive, isn't it? SymfonyLive. Like this? Okay. No. I'm going to select, or just do table, plop. Here I have the last tweet. Anybody talking about my presentation? So you can do the same with your Gmail account. You can do the same, well, they are provided as is, as example for the foreign data wrapper driver, but this can be very handy. So this means that if you get the right driver, you can almost see everything as a table or a set. PG is a relational search engine. This is very, well, once you have played a bit with CTE, saying, okay, I want this set, and I name it this way, it will have those fields, I join it with these sets. You can have even recursive CTE, sets that call themselves, so you can have, for example, Fibonacci. You can do, there is even one Mandelbrot set on the Postgresql wiki. Well, those guys are crazy. You can fetch relations between objects in one query, and you can mix them with, obviously, all the smart window functions we've seen. And it provides a nice data presentation layer for procedural languages. What we just said before is that presenting the data correctly is essential if you want to have simple computings. I mean treatments. How can you use that with PHP? First answer, PDO. Well, no. First answer is not a good answer because PDO gives you no structure, no type conversions, no class management, nothing. So this means that you will retrieve from PDO everything we've seen. This means strings with a curly brace when there are arrays and parentheses when there are objects. Very snap. DBAL and ORMs, the problem with them is that they are strongly coupled with tables. So this means that using them, we lose almost the flexible of sets. So this means that if I want to, well, I can, of course, overload methods to gain more accessors, but that won't replace window functions. They lack native extension types, operators. Well, maybe you can develop, of course, your own perpendicular operator or overlapping for times or whatever. But, well, as they have to be fully compatible with all databases out there, probably you won't find them. Important data presentation code layer in PHP. So this means that, well, once you have retrieved your table structure, you have to manipulate it so it suits your computations. Well, that's a personal experience using ORMs. In the end, you're just fed up with that, and you write specific SQL by hand using the ORM, which wins the only benefits of using them. So the first question, the last question I asked is, do I need them? Sometimes you need them. If you work on a project-based, you know that you won't probably change database from one day to another. And whenever you use a DBAL, it won't be as easy as this. But if you're, by example, coding a forum application or whatever, of course you need a DBAL because, well, you don't know on which database your application will run. So ask yourself the question, do you need a DBL layer. So here is the answer about managing all the structures we've seen. This one is for you, François. POM is not an ORM. POM is just an iterator above PDO, which means that it will retrieve everything we've seen previously in the SQL console, but it will know because it will have, obviously, schema maps of each table saying, okay, this is a varchar, this is an array of something, this is an entity, this is whatever. So we will convert them into the according PHP structure. Arrays will be PHP arrays. Hash store will be PHP associative arrays. Entities and objects, PHP, PostgreSQL objects will hopefully based on a PHP class. This is about the type converter system, which is the art of POM. You can, of course, because you can extend PostgreSQL types by providing your own types. I did show an example on POM's websites showing electrical transformer type. You can also, I used to have an example with the HTTP response type directly in a database. It fetches rows to elastic objects. We've seen that we can extend easily our sets by providing them more rows or less rows. If you want, by example, to hydrate like just a select box, well, hopefully you don't have to retrieve the whole table just to use one field name. So objects fetches from the hydrator has to understand that, okay, I have one field, I have n fields, more fields, less fields. This means that POM lets you put bananas into apple if you want, but of course you can take bananas and store them, fetch them into an apple class if you want. But after that, it's developers' responsibility to do that. It is loosely coupled to tables. In fact, you can even just declare a POM class based on a set, which is absolutely not a table. It maps sets to PHP iterator. Well, obviously, you don't fetch the whole result to an array just to eat your RAM. PHP schemas are turned into PHP namespaces. So, well, you won't have any name collision anymore. You will have a smart comment class, which is mapped to a comment table in the database schema. And let you devs play with all the nice features of PostgreSQL SQL language. Well, it supports PostgreSQL since PG 9.8.4, sorry, and it uses PHP 5.3, obviously, because it uses namespaces. It has some tools to do database introspection to generate the map classes based on your tables. After that, you can inherit from them because PostgreSQL can do multiple table inheritances directly from within the database. PHP can only do one parent inheritance, so obviously it won't work directly with POM, but anyway. And here is the website. Make your PHP code simpler by providing it the data it expects. It's not me. Obviously, it's more simple to test. Huh? Do you have some questions?
Can you make us a demo of POM, a few manipulations of sets?
Yes. This is, I won't do it like this online because I don't know if I've started my LXA container right now, but there is on coolcamps.org, like by example, introduction to POM. No, this is not what I wanted to do. Yes. Nope, that's the old presentation. Let me do that. Yes. This example, by example, is quite nice because it reads from Google Weather, which is an XML API. So what it does, well, here, this is the first step. Here is, by example, the result of a generation over there. Here is some code. I use the old composer, as you can see, because this tutorial has been made, I don't know, 2 or 3 months ago. And I declare a POM service, well, and here I define that I'm going to use a database using this DSN, by example. So please give me the first and the only database you have. Register the converter point to be able to, because point is not used by default by POM, by example. And return these services. So here, I can do with that just, thank you. I can do very easily with, where I have the code for that, POM service, this is not what I want. Well, I will show that to you. Aries, by example, what is generated by the scanner of the database. So you have, it's very like you've used already if you use Propel before or Doctrine or whatever. You have, in fact, you have to understand that it's not active record, which I really don't like. You have entities, for example, city over there, and this is like the class that is used to communicate between this class and the database, the structure of a city into the database. So here you have the structure of the city, and here you have all the methods that retrieve cities, and here you will put your own finders, your own SQL query to retrieve cities, obviously. And here you have the base city map, because this is what is fetched from the database, what is inspected from the database. And after that, what I've ended to do in this demo is that, no, over there. I ended in doing, well, such things. This is XML. In fact, there it is. What I did at the end is that, I don't have an example, I fetched directly the XML into a table using XML XPath to ensure that the XML is correctly formatted. Then I create a view that is doing all the XPath querying from this XML, and that outputs this. No, not this one. Just this one. This is an entity, which is this one. So I extract directly from the XML this information. But it's very costly to directly query XPath stuff. So this makes time, especially now, because I have one call every 4 hours, so now I have more than 100,000 records into the XML data. So if I do a select star from XML, whatever, it just takes ages to do. So what I do is I extend my table city by adding a new extra column, which is from the type of my view. So here, I can store directly from within the table a measurement entity. So every time I store a new record, XML record, I fetch the values from the view and store it into the city table to have the last measurement.